Great today. For those of you who do not know me, this is Dr. Nandi. I frequently go live on my channel and we discuss all kinds of math. I've also uploaded all kinds of videos uh, solving math problems and discussing math topics in my YouTube channel. So when you get a chance, please take a look. And if you like those videos, please give me thumbs up. Please subscribe to my channel also. Other than math video, I have also some shorts which are fun video, nothing to do with maths, just routine daily life, but some interesting shorts. When you get a chance, you can also take a look at those. So without further ado, let's get started. Today we are going to talk about the standard normal distribution. So it's a topic of importance in statistics. Standard normal probability distribution. That's what we are going to discuss about today. So when we are talking about standard normal probability distribution, we are talking about probability distribution of standard normal variable z, normal variable which is given by letter z. How is z defined? Z, which is the standard normal variable, is given as x minus mu over sigma, where x is value of random variable, any value which we are studying. Mu, this is to be read as mu, is mean of the probability distribution of the same random variable, Now you may be thinking, what is a random variable? Anything is a random variable, something that varies from person to person. Like say age, height, all of these are random variables. The same random variable. Okay, and sigma is the standard deviation. That means an average deviation from the mean. Standard deviation of the same random variable. Same random variable. So as you can see from the definition, z is deviation. Deviation means difference of the random variable from the mean divided by standard deviation. Standard deviation. Or in other words, z tells us how many standard deviations the value of the random variable, how many standard deviations the value of the random variable x is away from the mean. How many standard deviation the random variable x, remember x is the value of the random variable, It tells us, z-score tells us how many standard deviation you are away from the mean. That is the value of the random variable is away from the mean. Okay. If z is positive, that means x is greater than mu. That is, the value of the random variable is greater than the mean. And if z is negative, x is the value of the random variable is less than the mean. Random variable less than the mean is less than the mean, less than mu, if it is negative. As you can expect, if x is greater than the mean, then the numerator is positive. Hence, the value of the standard normal variable is positive. If x is smaller than the mean, the numerator is negative. Hence, the value of the standard normal variable is negative. Okay. So, since z is equal to x minus mu divided by sigma, okay, if we substitute x is equal to mu in the equation for z, we get z is equal to mu minus mu divided by sigma, which is 0 divided by sigma is equal to 0. What does it mean? It means the center of the standard normal curve is equal to 0, is equal to 0. Also, the standard deviation sigma is equal to 1. Okay. Center means I should write mu. So, thus, for standard normal curve, mu is 0 and sigma is equal to 1. Okay, so this is the standard normal curve. We have z, the standard normal variable, on the horizontal axis. It's a bell-shaped curve. Okay, the center is where the peak is the highest. As you can guess, this is the relative frequency or probability on the vertical axis. Probability on the vertical axis, and you have z values on the horizontal axis. But the important point for note, this is the standard normal distribution, this curve, normal distribution, this curve. Okay, so here the mu is 0 and sigma is 1. Okay, so on the center is 0. So at the center z is equal to 0, because that's how the standard normal curve is. Okay, so on the right side of 0 we have positive numbers in a number line, and on the left side of 0 we have negative. Okay, so suppose we go one standard deviation. Okay, so this is one standard deviation. That means this is a z-score of 1, this point on the right. And we go equidistance on the left. This is a z-score of -1 and this is +1. We draw two vertical lines and we want to find what is the probability that z is between -1 on the left and +1 on the right. So how do we find that? We use our calculator. We are going to use the TI-84 calculator. I will show it to you in a minute how to do the calculation, but we will press second verse and then number 2, which is normal CDF. Okay, so let's do it. So on our TI-84 calculator, we are pressing the second key first, then the verse key is in the third row, verse key, second and verse, then number 2. Number 2 will be normal CDF. So second verse, okay, then number 2 is normal CDF. It asks for a lower value under normal CDS. Lower value, we start our calculation from the left. Lower is -1. So type minus. Be careful for the lower. The minus you want to type is the one on the left of the enter button at the bottom right. Not the minus sign on top of plus. The minus on the left of the enter button. -1 is the lower. And since -1 and since on the right we stop at calculation at z equal to 1, the upper boundary, lower means lower boundary -1, minus next to enter and then 1, upper is on the right, 1, just +1 because we stop our calculation at z equal to 1. Okay, upper is just 1, so we type 1. Then the mean and standard deviation. Mean is 0, standard deviation is 1. These are already set up, don't touch them. And go down to paste and hit enter and enter. And you will get lower is -1, again minus next to the enter, upper is 1, mu is 0 and sigma is 1. So you will get the probability and then you do paste, enter and enter. Okay. So probability of -1 less than z less than 1 is equal to 0.68. That means approximately 68% of the data will fall within one standard deviation of the mean. Within one standard deviation of the mean. That means you go one standard deviation on the right, one standard deviation on the left, draw two vertical lines to meet the bell-shaped curve, and you will cover 68% of the data. But this is the same as the empirical rule. Now you know this result is same as empirical rule. Now you know where the empirical rule comes from. Same as empirical rule. Similarly, if you plug in, so suppose I want to find out what is the probability that the standard normal variable is between -2 and +2. So again, second verse, number 2. Now change it to -2 lower and upper is +2 and go down to paste and hit enter twice. Enter, enter. And you will see this is 0 point. Similarly, and again this is from the empirical rule. Similarly, P probability, let's write. Similarly, probability of -2 less than z less than 2 is equal to 0.95. This is also empirical rule. So now you see where the empirical rule is coming from. Okay. Now I already told you that the mean of this curve is 0, sigma is 1. Now let's look at the point z equal to -1 on the horizontal axis. What is this? This -1 can be thought of as -1 times 1. Okay, so this is the z value, we know -1, and this is the -1, the second one, -1 multiplied by 1. This is your standard deviation, because 1 is the standard deviation of the standard normal curve. So any of these points, again, this is 1, z is 1, is equal to 1, which is the z value, times 1. Okay, so any of these points can be thought of as z value multiplied by the corresponding sigma value. Sigma is always 1. So this is z. So any of these points is the product of, so z of -1 is a product of z times the standard deviation. The standard deviation is 1 in this case. Similarly, z of 1, 1 times 1, z value is 1 times the standard deviation is 1. Okay, so in more general terms, okay, if we think of the standard normal curve, the center is z is equal to 0, and let's think of an area in the center of the curve as 1 minus alpha. Area, so this is a different discussion. Area in the center is 1 minus alpha. 1 minus alpha. This is called, this is the area in the center. Okay, so area in the two tails is actually alpha. Area in the center is 1 minus alpha. Area in the two tails is alpha. Why? Because area plus area in the tails, if you add them together, area in the center is 1 minus alpha plus area in the two tails is alpha, is equal to 1, which is the total area under the curve. So area in the two tails is alpha. Area in the center is 1 minus alpha. So because standard normal curve, because the standard normal curve is symmetric, standard normal curve is symmetric, that means left half is equal to the right half, is symmetric. Area in each tail, area in each tail is alpha by 2. So this area is alpha by 2, this area is alpha by 2. So this area is 1 minus alpha, and this area is alpha by 2 in the right tail. This is the right tail. As you can see, it's in the right, and it's the tail because it's the tail end of the curve. Area of the right tail is alpha by 2. area of the left tail is also, area in the left tail is also alpha by 2. Why am I introducing this concept? Because then these z's are given the name z. This is on the right of 0, positive z, and it is signified or noted or written as z of alpha by 2, where alpha by 2 is the area in the right tail. For the left, it's on the left of 0, it will be negative, and it will be represented minus z with the area in the left tail, alpha by 2. Okay? So, as you will learn later, z alpha by 2 is the area, is the critical value of z, critical value of z with area in right tail, with area in right tail equal to alpha by 2. Right tail area is alpha by 2. Similarly, minus z alpha by 2 is a critical value with area in the left tail alpha by 2. Area in the two tails are equal. Alpha by 2 plus alpha by 2 is alpha, while the area in the center is 1 minus alpha. So if the area in the right tail is alpha by 2, the boundary, the z value is written as z alpha by 2. That means area in the right tail is alpha by 2. Similarly, the boundary in the left tail is minus z alpha by 2. Why minus? Because it's on the left of 0. Okay. So we will stop here today. In a later video I will explain what is alpha. Why is the area in the center 1 minus alpha? Okay, alpha is the first letter in the Greek alphabet. It's equivalent to English A. I'll stop here today, but this is not the end of the discussion. If you have still questions, you can always shoot me a question. I will get back to you as soon as possible, as soon as I read your comments. If you like my video, please give me thumbs up. If you like this video, please let me know where you are watching from and what is the time at your place. I really appreciate that. If you like this video, give me a thumbs up. Please share this video with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button, and at the same time, please click on the notify bell button. You'll be notified every time I upload a new video, which I do quite often. So please do not forget to watch me tomorrow. Thanks for taking the time today to watch my video. I appreciate that. Okay? Have a great rest of the day. Take care. See you. Bye.